Hello guys. Today we are starting the lecture new topic that is friction. Do you know friction we see in daily lives, number of applications we will see in daily life. Without friction we can't walk. Friction is supportive in walking. Okay. In daily life, some psychology in mind when friction comes into our mind, or something picture some loss of energy. Okay, some negative work done. But do you know friction is supportive also nation? Friction is supporting motion. Do you know? Yeah. Yes. Friction is supporting in nature. Okay. We can walk only through friction only. Okay. When we try to walk, our rear foot try to push back the earth and our uh, and the earth due to Newton's third law action and reaction feels a force in forward side. So we can walk through friction only. Okay. Another case of friction supporting motion, you can see riding of insects on the wall. That is only possible through friction. But most of the cases, we see the friction also against the motions. The appropriate word is relative motion. Okay, friction sometimes act as a opposition of motion. That is more appropriate. That is relative motion. Once sliding started, okay. Suppose that in this and look at the right hands. This is friction. Okay, this uh, this hand is sliding on this side. Similar type of two block problems you can see here. So in two blocks problem, one try to push back of other try to push back in forward direction. So in two block problems, we can see one block push backward the earth and earth push forward the lower block. And similar like when lower block tries to move in right direction, the friction will act due to upper block on lower block that is in backward direction. Okay, and due to Newton's third law, friction acts as in equal and opposite pair. So in upper block, the friction will be in forward direction. So we can see for upper block, the friction is supportive nature, and for lower block, the friction is opposing nature. Now, to understand the friction, okay, first remember when we say the friction, it means some roughness or irregularities between two surfaces. And to develop a friction, the contact is must, or we can say necessary condition. Without contact, friction will not develop. Okay. So friction generally we say the irregularities between two surfaces, or we can say the bonding intermolecular bonding between two surfaces. Okay. So, but sometimes you see two more plane surface. Okay, smooth surfaces that stick each other strongly. Why? Because guys, some of the student will see because friction, polish surface that is frictionless surface, so there should be no friction present between them. But do you know in nature there is no ideal frictionless surface? Okay, so everywhere friction is present, sometimes low, sometimes high. So between two polished surface, there will be a friction due to strong intermolecular bonding development. Are you getting my point? So to understand the friction, this graph is very important. Okay, and this graph is the friction force and applied force. When you see the nature of this graph, guys, remember this graph is very important. We can say this is the summary or backbone of friction chapter or soul of friction. We can say, guys, this is soul of friction. Okay, friction will exist in three mode. Okay, friction will exist in three mode. The first mode is, you can see this graph. First mode is that is static friction. Okay, friction can be static. Okay, in static nature, this is self-adjusting. Its value is self-adjusting as well as its direction also self-adjusting, guys. Okay, it can change its direction. Are you getting my point? And then when you increase the applied force, friction will it reach its optimum level or its maximum level, that is called the limiting friction, guys. Now the limiting friction depends on the friction coefficient, and friction coefficient means the roughness of the surface, and the normal reaction, okay, exerted by the another body or another surface, okay. So the F limiting, uh, F limiting, that is mu s into n, or we can say the maximum value of static friction, that is called limiting friction. And when limiting friction will convert into kinetic friction, okay. So kinetic friction will be slightly less than limiting friction, because when the friction reaches its limiting condition, what will happen? The irregularities breakdown. Okay, breakdown will occur, and what will happen? The value of friction will reduce, and that friction is called kinetic friction. Another type of friction, that is rolling friction. You can see in the diagram. In the diagram, the rolling friction because of adhesion of two surfaces, guys. Okay, one component of adhesive force will act opposite to the motion. Okay, that is called rolling friction, and it acts on a point. Okay, and this friction is arises due to deformation of two surfaces. Is it okay, guys? Up to here, I think everything is clear. This is the brief introduction, guys. This is the brief introduction. Okay. Okay. This is the introduction of friction. But the more important thing is application in exam, especially J and NEET. Okay. For J and NEET aspirants, the friction creates some little bit problems, guys. I know that is, I feel when I was in your time, I feel that type of, same problem I faced. But with the time I counteract that one, I overcome that problems. Okay, so same method I will teach you. Okay, so today we will see one important application of friction. Each students take is very hard, so that's why we are taking this one, and I will make you this topic easy for you guys. Okay, so keep with me, keep learning. Okay, enjoy. So now we are coming to the application part of the friction, that is two block problems of friction, guys. So now we are starting two blocks problem. So let's, guys, without wasting time, we are starting how to tackle these type of problems. Okay, today I will make you very easy these type of problems. Within seconds you will be able to give the answer of all type of problems. So the two block problems. Are you getting my point? So now the first work is to start this type of problem, that is draw the FBD. Okay. Remember, guys, FBD is the backbone of mechanics. Are you getting my point? Is the backbone of mechanics. Without this one, you can't do analysis of the forces. You can't analysis the equilibrium condition. Are you getting my point? So first work is draw the FBD, so that you are able to understand the direction of friction. Okay. These type of problems, there are generally two questions will be asked. First one, either friction will be asked. Second one, the acceleration of the block will be asked. Okay, that's it. So now the first one is, that is step one, that is draw FBD. Are you getting my point? The first work is, that is draw FBD, free body diagram. Okay. So now we are taking M2 and M1 block. Are you getting my point? This is M2 block and this is M1 block. So we can see the first force, remember this one, that is very easy, that is gravity. Okay, M2G. Now M2 and M1, that is attached, that is contact with surface. So that's why here will be normal reaction. I am taking this is N2. Okay. Now when you apply normal reaction, because this is internal force, okay, and due to Newton's third law, action and reaction opposite in nature, equal magnitude and opposite in direction. So N2 apply here. Any confusion? No. Now we come another force, friction direction, later we will see. Now make the free body of M2. Okay, M1, not M2, M1. M1, the first force is gravity, that is no problem, M1G. Now again you can see this block is in contact with the ground. So ground will exert again a normal force, and that normal force, that is different N1. Any confusion, guys? Okay, now the very, very, very important step, that is direction of friction. Are you getting my point? That is direction of friction. So direction of friction will be always be opposite to the relative motion, guys. very important word, mark in golden letters, that is direction of friction is always opposite to the relative motion. Are you getting my point? So you can see the M1 tries to move in right direction, in this direction, forward direction. Okay. But with respect to ground, M1 is moving in right direction. So with respect to ground, okay. So the friction will be opposite to the relative motion. Okay. With respect to ground, we are talking about. So the force of friction by the ground, that is opposite to the relative motion, okay, of M1 block. So this is the force, okay, due to ground. I am taking, this is F1, not F2. This is F1. Okay. Any confusion? No. Now you can see, or M2 block. Again, the M1 and M2 are attached. M1 M2 are attached. So there is a roughness between M1 M2. So again, there is a friction. Now you can see the M2 is here, M1 is lower block, M1 is try to moving in right direction. You can see. So this block try to push back this M1. Are you getting my point? You can see the movement of my hands. This is my pen. This is lower block. Okay, M1 block, it is moving in right direction. It is moving in right direction. So this, my upper hand is pushing back this M1 block. Are you getting my point? M1 block pushing back. You can feel this force. You can experience this force by doing this practical. So again, the direction of friction exerted by this is M2 block on M1, that is backward direction. Are you getting my point? This is very important. Okay, to find out the direction, this is very important. This and this force is F. Up to here, everything is clear. Now, again, the friction acts as an, according to Newton's, again third law, guys. Again third law. Again, the friction will be in opposite and equal and opposite in nature, okay, in both the bodies. So this is internal force. So on M2, this will be automatically in forward direction. Up to here, everything is clear. If you are able to draw this diagram, it means 90%, 50% work is complete. It is very important to take the direction of friction. And remember, in two blocks problem, friction is always opposite to the relative motion, not motion. In second block, you can see friction is opposite to the relative motion. Here, one external force is already here, that is F. Any confusion? And in M2 block, you can see friction is supportive in motion. In M1 block, friction is opposite in motion. Are you getting my point? But the friction is always opposite to the relative motion. Clear, guys? Clear? Up to here, everything is clear. Now, we are going second step. That is, show the औकात of friction. Show the औकात of friction. We can say औकात दिखा दो. In Hindi, we can say औकात दिखा दो friction. Now, what is the औकात of friction? So, remember the diagram of friction we have already discussed in this video. Okay, friction will be in three modes. First one is static friction. Second one is limiting friction. Third one is kinetic friction. Are you getting my point? So the critical point in friction, that is limiting friction. Well, critical point in the friction, my dear student, that is limiting friction. Okay, so friction either will be in one part, that is, if friction is less than limiting, that is static, greater than limiting, that is maximum value of friction, that is limiting. So either friction will be in static or in kinetic. If static, it means the body will be rest. If kinetic, body is moving. And limiting friction, there are two cases. If T is equals to 0, that is verge on motion condition. If after some time same force is applied, so the body will start to move. That is very important point. Any confusion up to share? Now the second step to solve this problem. Okay. First step, that draw the FBD clearly. Okay, it is very important. Or in FBD, we can do one work. That is find out of normal reaction. Okay, you can we can do this work also here. N2 we can write down, because this is balancing condition. There is no movement in vertical direction, so we can say in vertical direction the force will be balanced. So N2 will be M2G. Up to here, everything is clear. I think no problem. In second block for M1, we can write down N1 is equals to N2 plus M1G. Okay, and we know N2 is M2G. So we can directly write down M1 plus M2 into G. That is the normal reaction. Okay, that value is used for next step. So up to here everything is clear, and clearly we can see on the ground the two blocks. If we assume M1 M2 is single block, so both the blocks exerting contact force on the ground, and that value will be the total weight of 2. That is M1 plus M2 into G. Any confusion up to here? Now second step, that is very important. Now show the awkath of friction, the step second. Any confusion? What is the meaning of awkath? What is the meaning of show awkath? Okay, show awkath of friction. What is the meaning of this one? What is the meaning of this one, guys? It means you have to calculate limiting value, maximum value of friction. Okay. So for the first surface, that is between ground and M1 block. Okay. So I am writing down this is MFL1. So that will be, limiting case. The friction will be mu1 into N1. And N1 we have already calculated, M1 plus M2 into G. Okay. Any confusion up to here? Okay. Don't take the tension. Okay. I am take very easy. Okay, when our lecture will be complete, you will be able to solve within seconds. Within seconds, you can solve this type of problem. Because this is, and again, I'm telling to you, okay, most of the times it comes in the exam, okay, but this students generally, take it as a hard topic of friction. Okay, in friction, this is typical topic, hard topic. But I assure you, after taking my lectures, you are able to do all types of two-block problems. Any confusion? So the limiting friction of surface 2, that is mu2 into N2. So that is mu2 into M2G. So any confusion up to here, guys? Sorry, mu2 into M2G. Yeah, any confusion? No. I think this is the step second. Are you getting my point? Now the third step, and this is very important step. Okay. Third step is very, very important. Now the work started, two blocks problem. Okay. So the third step, that is now that check the value of friction. So the third step, there are two conditions. Okay. The first condition is called Satya Sath Nibhana. In the Star, Star TV, one serial came, Satya Sath Nibhan. Okay, so that I collaborate to solve the friction problem, and that step is called Satya Sath Nibhana. Satya Sath Nibhana. Okay, this is Satya Sath Nibhana. What is the meaning of Sath? It means both the blocks will move together, guys. Both the blocks will move together. Are you getting my point? Or we can say, when after marriage, two couples, two person becomes couple, or one single bond due to bonding becomes one as a unity. Are you getting my point? So they will move together. Both the blocks will move together. So we assume both the blocks. We assume both the blocks will move. We assume both the blocks will move. We assume both the blocks will move together. Are you getting my point? With common acceleration A. Okay. Common acceleration A. Are you getting my point? In connected bodies, we use this one also. Okay. We assume all the bodies is in single system. Same work we will do here in friction also. Okay. We will assume M1, M2 mass as a single system. Are you getting my point? This is M1 and M2. This is M2. This is M1. We assume this is a single system. Okay. Now, for this is F and this is friction. That is F. Now you can see if M1, M2 is moving together, it means moving started. So definitely this friction will be overcome. Okay. This friction will be already achieved its limiting condition. Okay. I am taking this an F2L limiting. So we can find out the acceleration, common acceleration A, that is net external force. Are you getting my point? Net external force divided by, acceleration is force by mass. So net external force divided by total mass. I think up to here, no confusion, guys. Any confusion? Simply you can say net external. First is F, that is applied, minus F2L or FL2, both are same, and divide by M1 plus M2. Now FL2 we have already calculated in this step, guys. Okay, in this step, FL2 we have already calculated. Sorry, FL1. Okay, not FL2. This is FL1. Okay, this is first surface. By mistake, I did this one. So once again. This is FL1. Any confusion? No. This is FL1, and we know the value of FL1, that is F minus mu1 M1 plus M2 into G divided by M1 plus M2. So I think up to here, no problem. Is it clear? It is very important step. Satya Sat Nibhana. This step name is Satya Sat Nibhana. Okay. Now both the blocks moving, same acceleration, that is A. Now first, for this surface, we have already calculated friction value, that is FL1. Okay. Now, we assume this one. This is not certain that our answer is correct. We are going in right direction. Okay. Just to assume. Now we will prove this assumption that is right. If this is right, both the blocks will move together. Otherwise, the breakup will happen. Okay. So the step force, check the value of friction. Step four, that is, guys, check the value of friction. Are you getting my point? Check the value of friction. Okay, so for body 2, we have already taken limiting friction. So we will check only for body 1. Okay, in this case, we will check only for body 1. Are you getting my point? If force is supposed in upper body, so in that case, we will check for lower body. Are you getting my point? In this case, the force in lower body, so we will check for upper body. Okay, whatever remaining body, we will check for that one. So in the FBD, you can see, guys, in the FBD, only F2 force is responsible to move M2 in forward direction. This is net force in forward direction or in right direction. This is responsible for M2 block moving. Okay, so we can write down directly, that is F2 is equals to M2 into A. A is common acceleration. We have already calculated this value. Up to here, everything is clear. I think everything is clear. Okay. Are you getting my point? My dear students, are you getting my point? Now, if it is coming less than limiting value of 2, FL2. If it is coming less than the limiting value of this friction, okay? The friction is present between this surface, S2 surface. If it is coming less than, okay, in only this condition, if this condition is proof, so we can say the blocks will move together. Are you getting my point? And this friction will be static. Are you getting my point? F2 will be static. So we have calculated the value of friction, that is F2. The value of acceleration, that is A1, we have calculated here. And in first block, here, first surface, the friction is FL1. Okay. If F2 is coming less than FL2, so both the blocks will move together. Now the step 5th. Okay, that is important part. Okay, now the step 5th, guys. Step 5th. Now what will happen? If the friction exceeds its limit? Okay. In Hindi we can say friction अपनी औकात से बाहर. So if friction is coming greater than FL1, friction अपनी औकात से बाहर. This step is called Sanam Bewafa. Sanam Bewafa. Are you getting my point? What is the meaning of this one? Breakup. Okay, first love, then breakup. What is the meaning of breakup? It means the sliding is started. Are you getting my point? Sliding started and both the blocks will move their different acceleration. Are you getting my point? Now we have to calculate that acceleration and friction. Again, it is very easy, guys. Now you can see the we are talking about again M1 block. So okay, sorry F2. By mistake, I write this one F1. Sorry, by mistake I'm writing F1 F2. This is F2. Okay, upper block. This is F2 and limiting friction of F1. It is less than is greater than limiting value of friction. Are you getting my point? Up to here everything is clear. Okay. So if F2, it means the friction between upper block and lower block. This is upper block, this is lower block. If friction is greater than the limiting friction between those two surfaces, what will happen? The sliding will start. It will move its path. It will move its path. But there is a condition for upper block. Are you getting my point? There is a condition for upper block. Because friction, it has a limiting value, FL1. Okay. Friction can't go beyond limiting value, guys. Okay. And for M2 block, you can see the only force, that is F2. This is responsible for moving. But F2 can go its limiting value. So the friction will be net force M2 into acceleration of A2 block. Are you getting my point? A2, acceleration of M2 block. Are you getting my point? So we can say A2 and that will be maximum because we are taking maximum value of friction. Okay. So that will be F12 divided by M2. Are you getting my point? FL2 or F12, limiting friction divided by mass. This is the maximum friction of M2. Are you getting my point? It will achieve its acceleration. Beyond this one, this will not achieve that acceleration. Are you getting my point? So for M2 block, the acceleration value will be FL2. We can write correct this one. FL2 will come. Okay, not 12. Okay, this is silly mistakes. You can correct this one. FL2. Any confusion up to here? For A2 we have calculated. Now A1 is again very easy. For M1 block, now everybody is very important right now. Okay, so this is M1 block. This is F. Now to move this block, FL2 should be FL1 should be overcome the friction by the ground and the friction by the bodies. Again, this will be overcome. Or we can say both friction will achieve its maximum limiting condition. In that case, the sliding will start. Are you getting my point? So in this case, the acceleration will be again, this is A1. Acceleration will be net force divided by mass. So net force is F minus this side F and this side, opposite side FL1 minus FL2 divided by M1. So we have find out the values of friction that will be limiting FL1 and FL2 and the acceleration of the blocks, that is A1, that will be F minus FL1 minus FL2 upon M1. We know FL1, FL2. So we have completed this one. Okay, guys. So this is the method to solve two blocks problems. Are you getting my point? This is standard steps. When you use this one, every type of two blocks problems you can do. So now we take some examples of two block problems. Okay, we take some examples of two block problem. So now this is the one example. Try to solve this question. Okay. So first step is draw the FBD. Okay, but when you start the problems, you follow all the procedure. But I am doing directly here. Okay, because last time, limited strength of videos. Otherwise, the video will be lengthy. So I am doing here directly. But you follow all the steps. Okay, when you comfort to use all the steps, then you can do directly also. Are you getting my point? So I'm assuming both the blocks will move together. Okay, and we can directly find out. So I am directly using the second steps. Okay, so we can say that is common acceleration A, that will be net force. Now this time the friction is not available because this is the smooth. So whatever value of F, both the blocks will move together. Okay. Whatever value of friction here for 10 kg, the blocks will move. Why? There is no friction between the ground and 10 kg block. Are you getting my point? A, we can directly, first the FBT, the second one is limiting friction. So we can find out limiting friction here, not common acceleration. So limiting friction here will be, okay, the limiting friction here is, no, limiting friction is 0. Okay, because this is smooth, mu is 0. So this limiting friction of FL2, that is 0. FL1 we can calculate, that is mu into 5G. Okay, 5 into G. G we can take here, 10 we can take. Okay, it is not mentioned, but 10 we can take. So that will be how much? 20 Newton. Are you getting my point? And the value of F is mentioned, that is 30 Newton. Any confusion up to here? I think no. So the acceleration of the now the second step is the common acceleration, that is A. Are you getting my point? So A is how much? Net external force. That is 30 minus here's friction is 0 divided by total mass. That is 5 plus 10. So the common acceleration comes out to be 2 meter per second square. Okay, the next step is we will check the friction. So free body diagram for, you can make this one, you can make this one. Are you getting my point? So I am taking 10 kg. Okay, in 10 kg, for 10 kg block, this block will move due to friction provided by 5 kg. Okay, this is F1. And for 5 kg, if you draw free body diagram, so this will be F1, this will be F. And both the blocks will be moving with same acceleration A. So we can write down F1 for 10 kg. F1 is equals to 10 into A. Any coefficient 10 into mass into acceleration. So acceleration will be, that is 2, we have calculated 10 into 2. That is 20 Newton. Any confusion? So F1, so it is coming approximately equals to, it is coming equals to FL1 limiting friction. Okay. Sorry, here G will be 9.8 we have to take. So this will be less than 20. Okay, not 20. This will be less than 20. So, but option is not available, less than 20. So this F1 will be greater than FL, limiting friction. Okay. But when you take 9.8 G here, so this FL1 should will come 20 Newton. But I think this is the previous exam question. So it is taking 20 Newton here approximate. Okay, and it is 20 Newton. So both the blocks will moving for some instant for same acceleration, 2, 2. Are you getting my point? But this is not correct answer. When you take G is 9.8, that is most accurate value of G. In that case, FL1 will be less than F1. Are you getting my point? So we can say this friction sliding is started. Okay, but I think this is NEET level questions. So we will assume this is approximate 20. Are you getting my point? 20. So it achieves the value of FL1. Okay, so both the blocks for some instant will move same acceleration. But after some instant, what will happen? The sliding will start. Even still sliding is started. But for, sometimes in the exam, it is not mentioned. According to your understanding, you have to do that type of questions. Okay. Now, the next question. Now, I will solve using whatever steps we learned right now. I will use that all steps. Okay. So that, for better understanding. Are you getting my point? So, the next question is very important. So, step by step, we will do. Again, the F value is 7 Newton. Okay. And the acceleration of lower block we have to calculate. Okay. Similar question, just like previous one. So I will solve this is one by one. So step first, that is free body diagram. So there are two masses. We make the free body diagram of two masses, that is 2 kg and 5 kg. This is 2 kg. This is 5 kg. So here this is smooth, but here there will be friction. Due to this friction will move, and here the friction will be F11, and this is capital F. That is given. That is 7 Newton. The second step is you have to calculate the limiting. Here is limiting, that will be 2 and 5 kg. Okay, and the value will be FL1, that is mu 1 into N1. That is mu 1 is how much? 0.5 is given to you, and N1 is 2G. Okay, again taking the value of G. Okay, be careful. So mu1 we can write down, that is 0.5, and N1 you can take, that is 2G. So kept the G as it is. So this will be 0.5 into 2, that is 1, and G. So the FL1, that is G. Whatever value later we will see. G Newton. Okay, that 10 Newton is using one another. The third step is calculate the common acceleration, that is net force. So F minus no friction between ground and smooth ground. So F minus 0 and the both the blocks, that is 2 and 5, that is 7. And F is given 7 Newton. So 1 meter per second square. This is common acceleration. Are you getting my point? Now check the value of friction. Okay, so friction will be, for second block we will check F1 is equals to 5 into A. Okay, so F1 will be 5 into A is 5 Newton. And the limiting value of friction, that is G Newton, or G is take to 10 Newton. So it is coming less than limiting friction. So we can see both the blocks will move together. A1, A2 will be 1 meter per second square. Are you getting my point? So our answer will be A. Any confusion, guys? No? So the next question is, again we will do same approach. Okay, so I am directly doing this one. F is 50 Newton. So first we find out the limiting friction of this one. So that will be FL1 0.4 into 5 into G. G I am taking 10 here. So this will be 20 Newton. Are you getting my point? This will be 20 Newton. And the common acceleration, that will be net force. F is 50. Okay, minus, this is again smooth. So this will be 0 divided by M1 plus M2. 5 plus 10. That is 15 divided by 50 divided by 15. Okay, so this will be 3 and this will be 10. So 10 by 3. Okay. Any confusion? No. So for directly we can check 10 kg. So F1, this is responsible for only friction is responsible for moving. So F1 will be, that is 10 into A. That is 10 by 3. So this will be 100 by 3, and this is coming, I think, 33.33. Are you getting my point? So friction in this case is greater than, okay, friction in this case is coming greater than, okay, friction in this case is coming greater than limiting friction. Are you getting my point? So the next step is Sanam B works for, are you getting my point? Breakup. So they will, so 10 kg. Now the next step, that is this step, okay. Step 4, Sanam wave breakup sliding started. So for F, M2 block, okay. That block, the M2 block, in this case, this will be 10 kg block. For 10 kg, the friction is responsible. So we will consider that is limiting friction here, okay. So that is limiting friction, and the 10 kg block 10 into this is lower block. So we can take this is 80. So and FL1, that is 20 into 10 into A2. So A2 will be 2 Newton. Are you getting my point? Now for A1, again A1 is easy. Make the free body diagram for 5 kg. 5 kg, this is 50 Newton, external force F, and this is 20 Newton. Because friction achieve this limiting condition. Okay, because after limiting, sliding will start. Remember this one. So acceleration of this A1, I am taking 5 kg mass. So that is how much? That is how much? A1 is equals to 50 net force, 50 minus 20 divided by mass. So this is coming 30 divided by 5, 6 meter per second square. Here guys, correct the value of unit. That is, any confusion up to here? So 2 or 6. Okay. So for 5 kg that is 6, and for 10 kg that is 2. So answer D is correct. Are you getting my point? Now the last is, there are two frictions. Okay. Again, there are two surfaces. So again, we use the same step first, that is draw FBD. Okay. So that I left for you. I am taking directly second step. I am calculating friction FL1 here, that is 0.4. This is how much? 10 kg. And this is how much? 15 kg. Any confusion? So point FL1, that is mu1 into N1. N1 is 10G, M1G. Okay. So that is 10 into G. G I am taking here 10. So that is how much? It is coming 40 Newton. Again, for limiting friction, limiting value of this friction FL2, that is how much? 0.2 into the total weight of this one, 10 plus 15, that is 25 into G. And this is how much? 50 Newton. Any confusion? Next step is, again we assume both blocks are moving together. Are you getting my point? So the common acceleration will be, that is how much? Net external force F. F is given, that is 90 Newton. Now this time FL2 will come. Okay, if you assume this is one block or a single system, okay, so here this friction force FL2 will come. This will overcome. Otherwise, both the blocks will not move together. Okay, so this will be 90 minus 50. Okay, FL2. F minus FL2 divided by total mass. So 10 plus 15, that is 25. So this will be 90 minus 40, that is 90 minus 50, that is 40 divided by 25. So this is 8 by 5, or this is 1.6 meter per second square. Any confusion? Now, the block A will move the friction between A and B, that is F1. So for 10 kg, when you make free body diagram, so this is F1. This will move in this direction only, friction. Are you getting my point? So this is net force F1 into mass into common acceleration, that is 8 by 5. So this is coming how much? 16 Newton. And we know the value of FL1 limiting friction is 40. So it is coming less than 40. So our assumption is correct. Both the blocks will move together. Are you getting my point? So the A1 will be, A2 will be 1.6 meter per second square. And the value of friction, that is F1 is equals to 16 Newton. FL2, that is 20 Newton. Sorry, FL2, that is 50 Newton. Okay. So correct this one. So now guys, okay. So I think we did two blocks problem. Now you can take any type of problem, use whatever step we discuss one by one. First, it will take some times. Give it time for one time. Now you will be champion after some times. Okay guys, so thank you so much. Jai Hind, Jai Bharat. Thank you.